All right, welcome. 7.3, solving systems by substitution. All right, so in our last class, we learned all about, I didn't write this down, we did it by graphing. So you would graph linear equations or a quadratic equation or a circle equation, and we would just see where the lines crossed. So that would be the intersection. You could have one solution, two solutions, no solutions. So you may want to refer to that if you need to. I also said, well, yeah. Okay, so 7.3, we're doing it by substitution. So there shouldn't be any graphing. You should just do it all by hand. I know a lot of you guys know how to graph equations on your graphing calculators, but if you don't show any work, then you're gonna be in trouble. So please make sure you show your work, and please, again, if you have any questions, let me know. So we know how to do it with graphing. We're going to do it by substitution. You've done substitution before, just using linear equations. So like, here's some examples. Here's the steps if you need to refer to that. So the first step is you're going to solve one of the equations for y. You could really solve for x if you wanted to, but many of the equations are already set up for y. So that's why I'm going to suggest that you solve for y. Okay, once you've solved one of your equations for y, then you're just going to substitute into the other equations. So let's just get started. So here, solve one of the equations for y, check. Okay, next we're going to substitute that in to the other equation. So y is equal to negative 2x plus 4. Now we're just going to substitute that in. So we'll have negative 7x minus 3 times what y is. Well, y is negative 2x plus 4 is equal to negative 12. All right, and then we're just going to solve. The next step, I think, was to solve for x by factoring, completing the square, or using the quadratic formula. Okay, well, here we don't need to. I guess our next page is we're going to be having quadratics. These are just two linear equations. So here we're just going to solve just regularly. So we're going to distribute first. That's the first thing we want to do. Well, in PEMDAS, parentheses, well, we can't simplify what's in those parentheses. Exponents, we don't have any. So next would be multiplication and division. So we would distribute the negative 3. So still we have this negative x. And then we'll do negative 3 times the negative 2 gives you a plus 6x. And negative 3 times a positive 4 gives you a negative 12 is equal to negative 12. Okay, so we did the multiplication and division. Now we're going to do the adding and subtracting so that we can get x by itself. So combine like terms, those are like terms. That gives us a negative x. And then we'll want to add 12 to both sides. Okay, and those cancel out and just give us 0. So we get negative x is equal to 0. And we're not wanting to look, we don't want to find out what negative x is. We want to know what x is. So we'll just need to divide or multiply both sides by a negative 1. So here would end up getting x is equal to 0. So that's great. We know what x is, but we don't know what y is. All of our answers will always, just like it was in our last unit, we need to make sure we have our answers, oh, it's right here, are written as ordered pairs. Okay, so we have the x. So for our answer, we have x is 0, but what is y? And so our step says plug the solution or solutions into each, that doesn't make sense, into either equation to find the corresponding y value. Okay, so a function, these are all functions. Functions are things where you can plug in an x and it will pop out a y. So here we can plug it into either equation, it doesn't matter. So here I'd maybe want to do the first one because it's already solved for y. So we'd do y is equal to negative 2 times 0 plus 4. And negative 2 times 0 is 0. So we'd end up getting y is equal to 4. So we put it into our ordered pair, and that would be our answer. So these two linear equations, they cross each other somewhere, or at this exact point, 0, 4. Okay, so this should look kind of familiar. You did this before in previous years. Okay, I think in class maybe I just skipped that part because you've been over that, but I'm going to go over these again. If you'd like to give it a try, that would be good for you. Okay, so here's another one. Again, first step is solve for y. You could also solve for x, but this one's really easy to solve for y for this equation. All you need to do is subtract 6x, and we just get y equals 16 minus 6x, and then we're going to substitute that in for y. So we'll have negative 8x minus 3 times 16 minus 6x is equal to negative 8. We'll distribute, so we still have this negative x, negative 3 times 16, so negative 3 times 16 is, delete, is negative 48. And then we'll do negative 3 times a negative 6 gives you a positive 18x is equal to negative 8. So now we just want to combine like terms. Here we have some x's. It gives us 10x. And then maybe we'll add 48 to both sides. So we'll get equals 40. We'll just need to divide both sides by 10. And we'll get x is equal to 4. Okay, so again, we still need the y value, so we can plug that into either equation that you want. Since we already solved this one for y, it's really nice to use that one. So we could do y is equal to 16 minus 6 times 4. That gives you 16 minus 24, or negative 8. Okay, that would be your answer, 4, negative 8. Okay, you want to maybe give this one a try. Solve for y. This one's really good to set up for y because it doesn't have a coefficient. So we could rewrite that as y equals x plus 1. And then we'll substitute that in. So negative 4x plus 8 times x plus 1 is equal to negative 24. We'll distribute negative 4x plus 8x plus 8 is equal to negative 24. Combining like terms, that gives us 4x, and then maybe we'll subtract 8 from both sides. We'll get 4x minus 32, and then we'll divide both sides by 4. X is equal to negative 8. And then we could plug that into that equation, get y is equal to negative 8 plus 1. So y is negative 7. So our ordered pair will be negative 8, negative 7. And then the last one for linear equations is, again, I'd probably use this one just because there's not a coefficient, but really it doesn't matter which one you use. It's nice to have it that way because then you don't have to worry about like plugging in fractions or things like that. So here maybe we will add 4x to both sides. So we'll get negative y is equal to 4x plus 11. And then to get y by itself, or get rid of that negative, is we'll just divide everything by negative 1 or multiply everything by negative 1. Basically just change the signs for everything. And we're good. So we solved it for y. Now we're going to substitute it into the other equation. So don't accidentally plug it back into the same equation. You'll get that there's infinite solutions, which is not what we're looking for. I mean, we did some examples where you had infinite solutions, but I mean, we had like a line on top of a line, things like that, but we never had a homework where we had to do that. So don't worry about that. If you end up having infinite solutions, then probably something went wrong. All right, so we substitute that in. We'll have 3x plus 7, and then we're going to substitute that in. Negative 4x minus 11 is equal to 23. Okay, and then we will distribute, just like we've been doing. We get 3x minus 28x minus 77 equals 23. Right, and then we'll combine these like terms. That gives us a negative 25x is equal to, and we'll add 77 to both sides. That gives us 100. And then we'll divide both sides by negative 25. Get x is equal to negative 4. Okay, and then we can plug that into either equation. Again, I would like to maybe plug that into the one that's already solved for y. So we'd get y is equal to negative 4 times negative 4 minus 11. That gives you 16 minus 11, which is 5. So our ordered pair would be negative 4 comma 5. All right, so let's get to the other stuff. So that was a review. You've done that before, probably in 8th grade. Now we're going to practice with quadratic equations. That is ax squared plus bx plus c, or even the circle equations. Oftentimes those are called also quadratics, but they don't make a parabola, so I don't know. I guess it depends on who says what. But so solving systems equations, again, we talked about that. We can do it by factoring. I would try that first. Completing the square or the quadratic equation. Okay. Okay, it says before you start solving, make sure that one side is equal to 0. So we'll get to that point. So we're going to do the same sort of thing. We're going to first solve for one of the equations for y. Okay, oftentimes, since quadratics and linear equations and circle equations, I guess not circle equations, but those first two are usually always solved for y anyways. So it doesn't really matter. This one's solved for y. Okay, so we're just going to substitute that in to the other equation. So we'll end up getting negative 3x plus 12 is equal to x squared minus 11x plus 28. Okay, and then again it says here, before you start solving, make sure you set one side to equal to 0. So we're going to need to take care of that. And usually we'd want to keep that leading negative, like the x squareds, to be positive. So we're just going to add 3x to both sides, and then we're going to subtract 12 from both sides. So that ends up giving us 0 is equal to x squared minus 8x plus 16. And then I would suggest seeing if we can do classes. So 16x squared adds up to give us a negative 8x. Okay, and that would have to give us negative 4x and a negative 4x. So we can rewrite that as x minus 4 and x minus 4. And then we just need to solve each of those parentheses to equal to 0. Okay? And a lot of you also realize that if a equals 1, it's just going to be the opposite of what's inside. So our two solutions would be x equals 4 and also x is equal to 4. So the same. And then we would need to, so since we have a quadratic, we have two solutions. And but we're still going to, our next step would be to plug it into one of your equations. I would probably suggest the linear, just a little easier. So you get y is equal to negative 3 times 4 plus 12. You see that's negative 12 plus 12, which is 0. So y y is equal to 0 for both of those. And our solution, ordered pair, would be 4, 0. Okay, so that's an example where we have two identical solutions, and we only really need to write down the one answer. Okay, so here's another example. Again, these are both set equal to y, so we can just set them up and say x minus 1. Plug that in for y is equal to 2x squared plus 13x plus 15. We'll subtract x from both sides and add 1 to both sides. We get 0 is equal to 2x squared plus 12x plus 16. Okay? So, to make it easier for yourself, what I would do, since we realize that there's a greatest common factor is 2, you can divide both sides by 2, and we just get x, or 0 is equal to x squared plus 6x plus 8. And then it might be a little easier, and we don't have to do it by grouping. So glasses, 8x squared, add up to give us 6. So think about that for a sec. What are two things that multiply to give us 8 and add to give us 6? Again, if you can get stuck, you can always start listing the factor pairs. So 1 and 8, 2 and 4. Those are the only choices. 2 and 4 add up to give us 6. So 2x plus 4x. Since a is 1, we can do the shortcut. So x plus 2 and x plus 4. And our solutions, we'll just, since a is 1, we can just say the answers are x is equal to negative 2 and x is negative 4. So again, what we'd do is we would set x plus 2 is equal to 0, would solve, subtract 2 to both sides, we'll get x equals negative 2, we do the same. That's how we get those solutions. All right, and then we have two unique x values. So we're going to need to plug those in twice for both of them. So again, I think this one's probably the best one to plug into. So we'll do y is equal to negative 2 minus 1, which gives us negative 3. And y is equal to negative 4 minus 1 is negative 5. So we have our x and y. We have our x and y. Our ordered pairs are negative 2 comma negative 3 and negative 4 comma negative 5. Okay, so I'd like you to try and do, obviously these ones are circles. Probably should have had you do that last one if you didn't. Okay, so circles, I'll do the first one, you do the next one. So we have one equation solved for y, so we're going to substitute that in for y. So we'll have x squared plus 2x minus 10 squared equals 25. And just remember, when we're using exponents, exponents are just telling us how many times we're going to multiply what's underneath it by itself. Okay, so we're going to multiply 2x minus 10 by itself twice. You cannot distribute exponents like that. All right, so then we'll need to FOIL or box method. So we still have this x squared. 2x times 2x gives you 4x squared. 2x times negative 10 gives you negative 20x. Negative 10 times 2 is negative 20x. And then plus 100 is equal to 25. Combine like terms. So those two, that gives us 5x squared. Here we got negative 4x, 40x. And then, again, we want to have our quadratic equation on one side and have it equal to 0. So we'll need to subtract 25 to both sides. That gives us plus 75 is equal to 0. If you can, I would always say divide both sides by the greatest common factor. So we can divide both sides by 5. Keep it balanced. So we end up getting x squared minus 8x plus 15 is equal to 0. Okay, it makes it much easier, and then oftentimes you can factor then. So 15x squared add up to give us a negative 8x. All right, so how can that work? Is maybe, our only choices are 1 and 15. Those are our factor pairs, and 3 and 5. So we'd have to do negative 3 and negative 5. So our solution, or our answer is x minus 3 and x minus 5 is equal to 0. And then our solutions, again, it's just going to be the opposite sign of the negative 3 and negative 5 since a is 1. So we'll have x is equal to 5, or maybe we'll do it the other way, 3, and then we also have x is equal to 5. We have our two solutions. We just need to find their y's that correspond. So we're just going to plug that in. I would plug it into your easier equation. So y is equal to 2 times 3 minus 10. That gives you y is equal to 6 minus 10, gives you negative 4. And then we'll do the same for when x equals 5. Get y equals 0. So our answers are 3 comma negative 4 and 5 comma 0. So try and do the next one, and then we'll go over it. Okay, so it's already solved for y. We're going to plug that in. So we'll do x squared plus negative 4x squared is equal to 68. Gives us x squared plus negative 4 squared is 16. X squared is equal to 68. That gives us 17. X squared is equal to 68. And then divide both sides by 17. I think it's 3 times. Let's see. 68 divided by 17. That was 4. So x squared is equal to 4. And then we need to square root both sides. And again, when we square root both sides, we need to make sure we do a plus and or minus. So we'll end up getting x is equal to plus or minus 2. Or perhaps the way I usually write them down, since we have like two solutions, would say x is 2 and x is negative 2. We're going to plug those into our equation. So I'd use this one because it's easier. So y is equal to negative 2 times 2 gives you a negative 8. And then the other one we have y is equal to negative 4 times negative 2 gives you a positive 8. So our solutions are 2 and negative 8 and negative 2 and positive 8. Okay. And then the last thing is word problems. All right. So it says define the variables, write the systems of equations, and then solve by substitution. Make sure you label. Okay. So it says all 231 students in the math club went on a field trip. So this is like a total. Some students rode in vans and that hold 7 students each, and some students rode on buses that hold 25 students each. How many of each type of vehicle did they use if there were 15 vehicles total? Okay, so first define the variables. Okay, our variables are going to be what we're trying to find. Okay, how many of each type of variable or vehicles. So we have number of vans, and also the number of buses. But they tell us that they use 15 vehicles total. So all of the vans plus all of the buses is equal to 15 vehicles total. So there's one of our equations. And usually one of your equations will be just like that. You'll have the two variables added together and then just the total of those type of variables, which is vehicles. Okay? And the other, for this other equation, so this is a total, and we also had all of the students, that's also a total. So one of our equations is going to be 231. Okay? We're also going to have to use the other two numbers, like 7 students for a van and 25 for a vehicle. So here we have 7 students per van plus 25 students per bus. So again, it's very similar. We're going to have both of our variables in both equation. We'll always have these totals. Usually they will give you those totals, and then we just need to plug in the other information for our equation. Okay, and if you make sure pay attention to like units, it will help a lot if you think about units. So if this is the number of vehicles for the vans, number of vehicles for the buses, total vehicles, here we have students. Students times the students per van, or I guess I'm not really, 7 times the number of vehicles, that still gives students, and this gives us students. Anyways, okay, sorry, that was probably a little too confusing. Say, Mr. Warner, stop trying to explain things. All right, so we have our two equations, and it's just like the ones that we did right here. So we have two linear equations, and we're going to want to solve those. Okay, so first thing you're going to want to do is solve one of the variables, solve or isolate one of your variables. So I would always start with use the equation that doesn't have any coefficients. So you could do v, solve for v, you could solve for b very easily. You could just subtract b to both sides. So you'd get v is equal to 15 minus b. Okay, and then we solve for v. We're going to substitute that in to our equation. So we'll do 7 times 15 minus b plus 25b is equal to 231. We'll distribute, so that gives us 70 plus 35 is 105. Make sure I got that right. Yeah, 105, and then we'll do minus 7b plus 25b is equal to 231. Combine like terms, and that gives us 18b. And then we can also subtract 105 from both sides. And we'll get 18b is equal to 231 minus 105 is 126. We'll divide both sides by 18, and we'll get buses is equal to 7. So there were 7 buses, and then we want to figure out how many vans there are. So we'll just plug that in here. 15 minus 7, that ends up giving you 8. So V is 8. All right, and they don't ask you for ordered pairs because that doesn't really perhaps make as much sense. So we'll just have 7 buses. We'll just write 7 buses and 8 vans. All right. Whew. So I mean, again, I feel like the hardest thing is coming up with your equation. And once you have that, then it's just the same as what we've been doing the whole time. So let's try a couple more examples. A field goal is 3 points, and an extra point after a touchdown is 1 point. In a recent season, blah, 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 made a combined total of 21 field goals and extra kicks for a total of 49 points. So they're saying 21 field goals and extra point kicks. It's not 21 field goals and some other number of extra kicks. All right, so 21 total field goals and extra kicks. So we can, if we want to say our variables could be field goals, maybe we'll call that a F for field goals, number of field goals, and maybe we'll do E for extra kicks, number of extra point kicks. Okay. All right, so we're going to come up with our equations. Well, they told us that a total of, well, let's just say this first. So 21 field goals and extra kicks. So field goals plus extra kicks, the number of field goals plus the number of extra kicks is equal to 21. And then it says that the total points is 49. Okay, well, we're still going to have our F and we're going to have our E, but now we don't want the number of field goals. We want to know how many points they got from each of those. Well, we know it says that the field goal is 3 points and extra kicks are worth 1. So here we have our two equations. It's basically the same thing. We just have different coefficients and constants, but other than that, it's exactly the same. So we're going to want to solve one of the equations. So maybe we'll say F. Maybe we'll subtract E from both sides. F is equal to 21 minus E. We'll substitute that in for F. So we'll have 3, 21 minus E plus E is equal to 49. 3 times 21 is 63. Minus 3E plus E is equal to 49. We'll combine like terms. That gives us a negative 2E. And then we'll also subtract 63 to both sides. So 49 minus 63 is negative 14. So we'll have negative 2E is equal to, maybe we'll just write it here, negative 14. Sorry if I'm running out of space. Okay, so now we have our equation kind of like this, and then we'll just divide both sides by negative 2. We'll get E is equal to 7. Then we'll plug that in for our equation to find F. So 21 minus 7 is 14. And you can always use your equations again and see if that makes sense. So field goals was worth 3. So 3 times 14. 3 times 14 is 42. And then we add 7 to that, and that gives you 49. So anyways, they just want to know extra point kicks was 7 extra point kicks, and then F was the number of field goals was 14. And you probably could just write your answer like that, but 14 field goals. All right. Here's some others where we give you equations. Basically, well, let's just read it. But you're going to basically do the same thing that we've been doing with our equations previously. So it says the revenue of a production of Wizard of Oz by a theater group is this. Okay, this is our revenue. It's the money that they get. Where T is the ticket price in dollars. The cost for the production is this equation. Determine the ticket price that would allow the production to break even. So basically, they're asking for the intersection. Okay? So they're both solved for y. We're just going to substitute. Maybe we'll substitute this one into the first equation. So we'll do 60 or 600 minus 50t is equal to negative 50t squared plus 300t. Okay, we're going to solve or move everything to one side. Since this is negative, I would probably move it to the other side. So here I'm going to add 50t squared and subtract 300t to the other side. So plus 50t squared and plus 300t, or minus. Okay, those would cancel. And we'll get 50t squared minus 350t plus 600 is equal to 0. Okay? Excuse the bells. All right. And then, again, what we've done before is if there's a greatest common factor, we should probably take care of that so it's a little easier. So we can divide both sides by 50. And I'm just going to write it over here. So we end up getting t squared minus 7t plus 12. Okay, make sure I don't make mistakes. Yep. Okay, and then we're going to do the same thing. You can do factoring if it works. So let's see, 12t squared add up to give us a negative 7t. What could make that work? So 1 and 12, 2 and 6, 3 and 4. Oh, got to be 3 and 4. So we're going to do negative 3t and a negative 4t. So we can write our equation. Since a is 1, we can do t minus 3 and t minus 4. Okay. And then our two solutions will be t equals 3 and t is equal to 4. And we'll substitute that into our equation and see what we get. So I'll use the first or the second one right here because it's easier. So y is equal to 600 minus 50 times 3. You could also do y is equal to 600 minus 50 times 4. Okay, and we end up getting y is equal to 450, or y is equal to 400. So we have two solutions. It'd break even when we have 3, 450, or 4, 400. Okay, let's see if that makes sense. So it says, determine the ticket price that would allow the production to break even. All right, so ticket price, T is ticket price. Oh, I see. Okay, so they can break even if the ticket price, if they have the ticket price is $3, then they have to sell 450 tickets. If they have $4 tickets, then they have to sell 400 tickets to make it even. Okay, so those would be our two choices. All right. And then D, basically the same sort of thing. Revenue of a company producing electronic components is this equation, except there should be a Y. or I guess it's, since we're using C's, we should probably be using C's. Okay, where X is the price in dollars, so X is dollars for each component. The cost for the production for those components is that equation. Determine the price that will allow the company to break even. Okay, so you do the same sort of thing. They're both solved for C, so we can set them equal to each other. So 60x minus 10 is equal to negative 30x, or 20, negative 20x squared minus 50x plus 200. Okay, again, since we have a leading negative for our quadratic, I would probably suggest moving it to the other side. So just add everything to the other side. So plus 20x squared plus 50x minus 200. That all cancels, and we end up getting 20x squared plus 110x minus 210 is equal to 0. Okay. It looks we can simplify. It looks like we can't divide everything by 20, but we can divide everything by 10. Basically, we'd end up getting 2x squared plus 11x plus minus 21. And then we can see if we can factor. So 2x squared times negative 21, that gives us negative 2 times 21 is negative 42 x squared, and adds up to give us 11x. So here maybe we'll do our factor pairs. We can do 1 and 42, 2 and 21, 3 and 14. Oh, and that works. So we can make that work to make us 11. We'll just need to choose 14x minus 3x. Okay, but we can't use the shortcut because A is not A is not 1, so we need to do it by grouping. So we're going to substitute that in for 11x. So we'll have 2x squared plus 14x minus 3x minus 21 is equal to 0. Okay, so here we cut it in half. We do it by grouping. So we can factor out a 2x, and that leaves us with x plus 7. And here we can factor out a negative 3. That leaves us with an x plus 7. So we can factor out the x plus 7, and that leaves us with 2x minus 3. Okay, and then we solve each of those. So we'll have one that will be x equals 7. But here we're going to need to set that equal 2x minus 3 is equal to 0. So we'll need to add 3 to both sides and divide both sides by 2. So we'll get x is equal to 3/2. And then we'll plug those into our equation, probably the easier one of the two. So C is equal to 60 times 7 minus 10. Okay, that gives us 420 minus 10, which is 410. So one of our solutions is 7, 410. And then the other, 60 times 3/2 minus 10. That's 90 minus 10, or 80. So our other one will be 3/2, 80. So let's see, does that make sense? So determine the price that would allow the company to break even. So C is the component, cost of the component. So that you have to sell the components for $7, and they'd break even at 410, or they have to sell 410, or they'd have to sell their components for $3.50, $1.50, and sell 80 components. Okay. All right, so if you have any questions, I feel like the word problems, I know they're kind of difficult, but you can do it. Come and get help if you need any. Okay, all right, we'll see ya.